having minima, at 1 it's having maxima, at 2, I substitute here 2, sorry, this is still it is our first derivative. Let me find out second derivative also. So differentiating this function, let me differentiate this one second. Differentiating second further, then I have to check differentiating second with respect to x. We get this is d square y upon dx square. If I directly check, then we will check in this interval because interval is given to us. Okay, so we are, or we can solve it. Then solving it only within these two values. Okay, points value in points will come up, but we have to find out in this interval. So they are simple because interval is given, so we can take 0, 2, or in between means 1. Only if I take integers values. So let me check what are the values here. So d square y upon dx square, differentiating this again. This is 12 here, 36 x square, 36 x square minus 9 to the 18x. Okay, this is minus 12 only. Now substitute the values here. Now we see if x equal to 0, this is minus 12. So at x equal to 0, it's having negative values. In this interval we have to find out. So at x equal to 0, sorry, at x equal to 0 in this interval, because interval is given to us. So at x equal to 0, d square by dx square at x equal to 0. If I take in this interval, so at x equal to 0, this value is 0, 0, negative, less than 0. The function will have maximum at x equal to 0. Okay, so the function will have maximum. The maxima will lie. Let me write here maxima will lie. And at x equal to 1, because in this interval I have to find out d square by at dx square at x equal to 1. If I find out what is this value, this is 1, that means 36 only. It will be 36 minus 18 minus 12. It is 30, 12, 12 and 18 minus 30, and 36 is a positive value. So minimum will lie at x equal to 1. So at x equal to 1, minimum will lie. So minimum will lie. Okay, so in this in between interval, the function is will have minimum value. Okay, at x equal to 1. Now at x equal to 2, if I substitute, let me find out at what is the value at x equal to 2. Because this interval is given, we have not to require any interval because any values to calculate, because this interval is given to us. So within this interval, at x equal to 1, this is positive value, so minimum will lie. At x equal to 0, it is negative function will have maximum value. Okay, so it's open interval, we cannot take 0 and 2, but we have to just check that at 0 the function is having maximum value, at 1 it's having minimum value, at 2 let me check what is the 2, d square by dx square at x equal to 2 will be 36 into 4, 2 square, minus 18 into 2, okay, minus 12, this is minus 12, okay, it will have what's the 24, okay, 2 and 6 for the 12, 144, this is minus 36 minus 12 with positive value, because this 144 is greater value than sum of these two. With positive value, it means it's having minimum value at x equal to 2. So maxima at x equal to 1, minima, and at x equal to 2 also, any further the value is minimum. That is there. So minimum will lie. So minimum will be there. Okay, so this is the condition in this interval. In this interval, we have checked at 0, at 1, in between, and at 2 also. At 1 and 2, the function is minimum, but at 0, it is maximum value. It's having maximum value. This is the investigation of the function in this interval. We have done this. Okay, this is the fourth question. Now let me take the fifth question. What the question number 5 says? question 5 says here that find the maximum and minimum values of the, okay, here values we have to calculate. For values there is a different method, or this is a further values we have to find out. So this is question number 5. Now question number 5 says that find out maximum and minimum values. Let me check them. Okay, so here function given to us is y equal to, let me take 8x5, this is minus 15x4 plus 10x square. This is first equation, equation number 1. Okay, so we have to differentiate it again. For maximum minimum, the same process, differentiating first with respect to x, we get this is dy dx is equal to 40x4, 8 5 is 40, minus 15 for the 60 into x cube. This is plus 20 into x square into this. Okay, so let me check. Putting dy dx 0 for maxima and minima. For maxima and minima, we always solve like this: dy dx equal to 0. Okay, this implies that 40x4 minus 60 into x cube plus 20 into x equal to 0. If I take x common, and 20 is also common, 20x if I take common is 2 into x cube, first one 2x cube, minus 3 into x square. This is plus 1 only, 20x we have taken common, equal to 0. Okay, so this is the function here. So at x equal to 0, first is x equal to 0, x equal to 0, 20x equal to 0, and this 2x cube minus 3x square plus 1 equal to 0. If I substitute here 2 plus 1, positive x equal to 1. So if I solve it for x equal to 1, let me solve it further by remainder theorem, that is 2x square x minus 1. If I have to write here, this is 2x cube, same value, but minus 2x square will come up. For that we have to remove, write here 2x square positive to remove that value. This is minus 3x square plus 1, 0. Further 2x square into x minus 1. We could divide by x minus 1, because x equal to 1, if we substitute, it is 0. That means x minus 1 is a factor of this. If I divide this whole function by x minus 1, then we can get other quadratic equation. That is also possible, but let me solve it by remainder theorem. So we write x minus 1 with this one. This is 2x cubed, so we can write 2x square into x minus 1. We will get 2x cubed minus 2x square. 2 minus, to remove minus 2x square, we have to substitute here plus 2x square, but sum of these two will be minus x square plus 1, 0. Here this is 2x square x minus 1. Here it is minus x minus 1. Okay, so again minus x into x minus 1. If I substitute, be minus x square plus x. Remove that minus x, we have to substitute for 0. This is throughout 2x square into x minus 1 minus x into x minus 1 minus, if I take common, this is x minus 1 equal to 0. This is x minus 1 throughout common. This is the remainder term. We have got 2x square minus x minus 1 equal to 0. Okay, so this is x equal to 1 also. Here we get 3, okay, this function as 20 into x minus 1 into another function is 2x square minus x minus 1 equal to 0. Okay, so these are the factors of this function. Now let me further solve it. 2x square minus x can be written as, okay, this is 2x square minus x minus 1. So minus 2x is to be differentiated. 2x square minus 2x plus x minus 1, okay, equal to 0. Here 20x into x minus 1. factors of this is 2x. If I take common, this is nothing but x minus 1 plus 1 common, so x minus 1. Okay, this is equal to 0. So from complete functions are 20x into x minus 1. X minus 1 again comes into 2x plus 1 equal to 0. Here we get x equal to 1, x equal to 1 two times, and then x equal to minus half. 2x plus 1 equal to 0. If x equal to 20x equal to 0, that means x equal to 0. X minus 1 whole square equal to 0, that means x equal to 1. Second value. 2x plus 1 equal to 0, because multiplication of these factors equal to 0. Then this equal to 0, either this equal to 0, or this equal to 0, or this equal to 0. So these are the three values we have obtained. Now substituting these values and check whether maximum minima lies, and if maximum minima whatever lies, then we find out the maximum value or minimum values, and the greatest or maximum value or largest value. Okay, largest or smallest values we have to find out. Let me differentiate this further. Second derivative of this function, this is second equation. So differentiating second, again with respect to x, again we get differentiating this is d square by second derivative dx square equal to 4 4 is 60, that means 160 x cube minus 6 3 is 80, 180 x square plus 20 only. Okay, this is 6 3 is 80, 18, 180. This is 4 4 is 16, 160. This is x cube, this is x square, and plus 20. Okay. Now substituting values, what we get? D square by dx square at x equal to 0. The first value. We see here that at x equal to 0, this is 0, this is 0, but plus positive. Equal to 20, which is positive. The minimum will lie. So minimum at x equal to 0. Minimum value we will calculate. Second, d square by upon dx square at x equal to 1. What is this value? This is 160 positive value minus 180 plus 20. This is 180 plus minus 180, 20 plus 160, 180 is 0. So neither at 1, neither maxima or minima. So neither maxima nor minima. Neither maxima nor minima at x equal to 1, nor minima at x equal to 1. Okay. So x equal to 1 is checked. At x equal to 0, it's the smallest value because positive was there. So max minimum will lie, and at x equal to minus 1, that we check. And finally, d square by dx square at x equal to minus half will give us this value. This is 160 into, this is minus half, that means minus 1.8. Okay, 1.2 whole cube, that means minus 1.8. This is minus 180, it will be 1.9. 1.3 whole square, that means positive. This is whole square positive value plus 20 as it is. So what we get here, 8 to the 16, that means 20 negative value. This is 9 to the 18 minus 20 again. This is plus 20. 9 to the 18 is minus 80, and this is also minus 80. Okay, 8 to the 16. So 20, 20 negative positive, 120 cancel out. It's less than 0. Maxima lies at x equal to minus half. So what is the maximum minimum values then? So let me. So there are two minima at x equal to 0, maxima at x equal to minus 1.2. At x equal to 1, neither maxima nor minima. So these two values we have to calculate. The largest value or maximum value. Let me calculate. So what are the maximum and minimum values? So that we have to substitute. This is the final point here. I mean, what we have to do, how to find out maximum minimum value. Largest or smallest value we can find out after substituting these values here. So at x equal to 0, thereby minimalize. What is the minimum value then? So the smallest value Here we have to find out the smallest value. Okay, at x equal to 0 will be, substituting here by 0, substituting x equal to 0 here, y at x equal to 0, here x equal to 0 will be, this is 0, this is 0, this is 0, 0 only, 0. So y minima is 0. So minimum value is 0. What is maximum value? Y at x equal to minus half, this is maximum value, or largest value will be, here it is, this is 8 into minus 1.2 whole 5 minus 15 into minus 1.2 whole 4. This is plus 10 into minus 1.2 whole square. Let me solve them. What is the final value? So that would be the answer. Largest value, I mean maximum value. Largest value is what? That is what? Let me solve it. 8 into 1.32, but negative value because it's odd number. It is negative. 8 5 ja or 8 4 ja 32. Minus 1.4. This is minus 15 into positive 1.16. 15 upon 16. This is plus sign. 10 into 1.4. Let me further solve it. This is minus 1.4 minus 15 upon 16. This is plus 5 by 2. Okay. 2 to the 4 and 2 5 the 10. Okay, so this is, if I take 16 common, let me take 16 common here. So 4 4 the 16 minus 4. This is minus 15 plus value. It will be 2 8 ja 8 5 ja 40. So positive 19. This is minus 19 plus 40. Minus 19 plus 40, that means 21 upon 16. 21 positive value upon 16. This is maximum value. 21 upon 16. This is the maximum value or largest value here. Largest value at x equal to 1 is minus, 21 upon 16 that we have calculated. So this is 21 upon 16. Largest value. This is the largest or maximum value. Largest or maximum value. Okay, this is the answer. So 0 and this 0 minimum value or smallest value and maximum value is 21.16. Okay, so these are the answers here. So this is fifth question. Now sixth question, if I have to solve the sixth, seventh, and up to 12th questions, they are left over. So, okay. So question number 6 here. Let me check. Question number 6 says find the maximum and minimum values of the